Today I'll be picking up where I left off in video number 8 with a more detailed description of the stator arm, and I'll also be showing you how the stator arm can be used for motive force. Now, before I do get started though, I'd like to first apologize for any disturbing background noises that you may hear. I'm taping during the daytime, and I live on a busy highway, very close to the highway. There's always trucks, cars, and motorcycles going by, so I hope that doesn't disturb anyone. Now, instead of placing my hand right in the way and obstructing your view, I'm going to be using a little pointer, which is simply a piece of copper wire. At the very top, you can see I'm pointing to the right front upper frame member, which is a PVC elbow, 1-inch PVC elbow. Now, extending down from that elbow is a 1-inch PVC pipe that runs all the way down to the PVC elbow at the bottom of the frame. Okay, and now right here we have a 1 1/4-inch PVC elbow, which is the main support piece for the stator arm, and which allows the stator arm to pivot on the 1-inch PVC pipe. Now, inside of this T-fitting is a 1 1/4-inch PVC pipe, and up at the top it's a very short piece, about a 1/2 inch long. It comes down to about here. Down at the bottom it's longer. It extends up about 1.25 inches to about here. Now, the reason I cut this end of the T-fitting shorter was because I wanted to get more height on the stator arm. Once I had it adjusted so that the angle over here, which slopes down towards the wheel to the same precise angle of alignment as the wheel is built on, which is 8 degrees. Once I did that, I found that I was very close to the wheel, so I decided to raise my stator arm T up as far as I could on the 1-inch pipe. Now, the 1 1/4-inch pipe inside of this, it rides on the 1-inch pipe, and it fits it fairly closely, although there is a little bit of play. And so I drilled and tapped the T with 1/4-inch, 1/4-20 threads, and I've inserted 2 nylon bolts here, 2 nylon machine screws, and I use these to tighten up the play here on the T, so that it doesn't feel wobbly and loose as it rides up and down on the 1-inch pipe. I leave it just snug, but not tight enough to inhibit pivotal movement of the swing arm. And then when I get it into the correct position, I can lock it up using the 1/4-20 thumb screws at top and bottom. Okay, now I'm going to come down a little bit further. You can see that there's also a 1 1/4-inch pipe in here. This extends 1 1/4 inches over this way and 1 1/4 inches over this way. So, you know, that's a fairly good length of pipe, and it's in there very securely. I haven't cemented it in. It fits so tight that I didn't need to really. I simply put in a locking screw, a number 6 screw, at the sheet metal screw up at the top. That's the same thing I'm using for the frame tightening screws. No part of the frame is cemented, and the reason I haven't done anything like that is because I want every part of the frame to be able to be taken apart and reconfigured as I decide to maybe modify something or add another apparatus. So that's my reason for doing this all with screws. And this is what I'm using for the screws. You can see here. I buy them by a box of 100. You probably need 2 boxes anyway to do this. It's about $2.50 for a box of 100 screws. Now these are magnetic in that they'll be attracted to magnets. They're zinc-coated steel. However, I find that the screws that I'm using are far enough away from the magnets so that there's really no interaction that amounts to a hill of beans, really. So I'm not worried about that. For any of the other hardware, I am using stainless steel. So take note of that. It's a good idea to use stainless steel because it's non-magnetic. It's strong. It's non-magnetic. I'm going to pan down a little bit further so you can see the rest of the stator assembly. You can see that I have a locking collar here underneath the stator swing tee, and this locking collar also has 1 1/4 inch pieces of pipe inside of it and fits closely to the 1 inch pipe, PVC pipe below that. I have locking thumb screws here on the collar so that I can adjust it at any height I want. And the benefit of that is that it acts as a safety device, keeps the stator arm from dropping down onto the rotor magnets or the wheel rim, and allows me to swivel the stator arm. This would be the swivel point right here where the T is, and I can easily swing it out over the wheel or away from the wheel to make adjustments that way, and then lock it in place. Okay, now let's take a little bit closer look at the stator mounting block. The stator mounting block is right here, and that's mounted to another PVC tee, and I use 1/4 inch stainless steel bolts to do that. And on the inside of the tee that I showed you in the last film, I think, there's a nylock stainless steel nut and lock washer which secures that. Also, I meant to use stainless steel screws to fasten the hard drive magnet up to the mounting block, but I couldn't get the length that I wanted locally, so I opted to use brass screws instead, and stainless steel nylock nuts. Okay, now I see I'm just about out of time, so I'm going to say goodbye for now. Catch you on the next film.